Welcome to Lesson 1, Matching Equations and Graphs. In this video, we'll continue to match equations with linear graphs, where the linear graph could be in the form of an oblique line or a horizontal vertical line. Example 1, we have 5 different graphs that have to be matched with one of the 5 different equations listed below. So we start with graph A. Here we have a vertical line that passes through the x-axis, so it would be an equation of the form x equals some number a. And because it passes through -2, we have x equals -2. So that matches with equation 2 down below. Now I'm going to look at graph E, which is a horizontal line. This passes through the y-axis, so it will be of the form y equals. Here we'll have y equals -2. Now looking at the equations listed below, equation 4 is the only one that has a y variable with no x variable. So I'm going to try simplifying 2x minus 1 equals -5 to see if I get y equals -2. So I can start by adding 1 to both sides. So I get 2y is equal to -4. Then I'll divide both sides by 2. And that gives me y equals -2, like I wanted. So graph E matches with equation 4. Now for graphs B, C, and D, I'm going to pick a point on the graph and then plug into each equation, see which one it satisfies. Now the point I'm going to pick should be unique to that graph only, as discussed in the last video. So for graph B, if I pick the point 1, 1, I want to look at graphs C and D to make sure that they don't also pass through 1, 1, which they don't. So it's a good point to use. So I'll start by plugging that into the first equation, x minus 4y equals 2. So x is 1 and y is 1. So I get 1 minus 4, which works out to be -3. Now -3 is not equal to 2, so it's not going to be equation 1. So we can try equation 3 now. 1 is equal to 2 times 1, take away 1. 1 is equal to 2 take away 1, or 1 is equal to 1. So it works in equation 3. Now looking at graph C, if I look at this point here for a second, 2, 0, 2, 0 is also on graph D. So that's going to be a point that I'm going to want to avoid. Instead, I'm going to pick this point here, which is 0, 3. So I'll plug that into the first equation. X is 0 and y is 3. So I get -12 is equal to 2, which is not true. So it doesn't match equation 1. It should match equation 5. So let's plug it into 3x plus 2y equals 6 to make sure. So 3 times 0 plus 2 times 3 gives me 0 plus 6, or 6 is equal to 6. So it works in equation 5. So graph D should work in equation 1, but let's pick a point to be sure. So this point is -2, -1. X is -2 and y is -1. That gives me -2 minus -4. When I subtract a negative, I change the sign, so it's really -2 plus 4, which is 2. So 2 does equal 2. So D does match equation 1.